Okay guys, so what we're going to do today is we're just going to review our functions that we've been graphing and how to do it, and then practice a little bit. So we're going to do both reciprocal functions and also rational functions, just a little cheat sheet. Okay, so first off, we'll do reciprocal functions. Remember, I'm going to be somewhat quick. This should all be review, and then I'll give you some practice here. But this guy, the parent function for a reciprocal is just 1 over x. And that function looks something like this right here if we were to graph it. All right. And we have a vertical asymptote at x equals 0, a horizontal asymptote at y equals 0, and that also gives us our domain and range restrictions. Okay. When we want to shift that function around at all we have to do is change some numbers, add or subtract some numbers, and that's how we can shift things, move them left, right, up, down, or also stretch or reflect it. So H, remember that's our horizontal shift. So plus actually makes us go to the left, minus goes to the right. And then K is our vertical shift, up or down. Plus is up, minus is down. Right? If A is negative, that's when we reflect over the x-axis. If A is greater than 1, we have a vertical stretch. If A is between 0 and 1, we have vertical compression. And remember, the way that we can find our vertical asymptote and horizontal asymptote when we have these shifts going on, our vertical asymptote is just going to be our left or right shift. Our horizontal asymptote is just going to be our up or down shift. Pretty easy. All right, so let's take a look at these two examples real quick. Example 1, we have 1 over x plus 1 minus 5. So this guy's going to be shifting left 1 and down 5 by looking at my numbers there, right? So that gives me my vertical asymptote as left 1 is negative 1. Horizontal asymptote down 5 is negative 5. And remember, those also give us our restrictions. So if I were to graph this guy, I would have a horizontal asymptote at negative 5. That's something like this right here. Right? And then I'm also going to have a vertical asymptote at x equals negative 1. And my graph would look something like that. Okay, for number 2 here, you'll notice we have a negative out in front, so we're reflecting over the x-axis. And it looks like we're also going left 3. And then because it's a 2, that's also a vertical stretch. Right? So the left 3 tells us that our vertical asymptotes will be at x equals negative 3. And we haven't gone up or down at all, so that means our horizontal asymptote is at y equals 0. So for our domain restriction, we can't equal negative 3. For our range restriction, we can't equal 0. So I'm going to plot these guys. Horizontal asymptote at y equals 0. Vertical asymptote at x equals negative 3. Remember, this guy is reflected over the x-axis, so it's actually going to be flipped a little. It's going to be something more like this. Okay, so that's reciprocal functions. And then what we learned about yesterday were rational functions, which remember they're in the form of one polynomial over another. Right? So first off, to find out the x-intercepts, we just set the numerator equal to 0. Okay, for vertical asymptotes, we set the denominator equal to 0 and solve. And then for horizontal asymptotes, we have 3 situations that could possibly occur. We're looking at the degree of our numerator and our denominator. Remember, this is our numerator, this is our denominator, p and q. If the degree of p is greater than the degree of q, we have no horizontal asymptote. If the degree of p is less than the degree of q, we have a horizontal asymptote at y equals 0. And if they're equal to each other, we have a horizontal asymptote equivalent to the leading coefficient of p over the leading coefficient of q. And then for holes, remember that's just like a break in your graph. Okay, all you got to do is you set the canceled factor. So if you cancel anything, that's when a hole appears. You set it equal to 0, and that'll give you your x value. And to find the y value, okay, you just plug the x into your equation. So let's try out 2 examples and then we'll get you practicing. So I'm going to go somewhat quickly through them. This guy, first I can simplify it by factoring that difference of squares, x plus 3 times x minus 3. Check to see if anything cancels, it doesn't. My x-intercepts, I set my numerator equal to 0. I'm going to have 2 answers here, right? X plus 3 equals 0 and x minus 3 equals 0. So I have positive 3 and also negative 3. So I actually have 2 x-intercepts. Holes, I don't have any because nothing canceled. My vertical asymptote, I just look at my denominator. I set it equal to 0 and solve. That's negative 2, right? And for my horizontal asymptote, I just check out my degrees. It looks like the degree of my numerator is bigger than the degree of my denominator. That's this first one. So I don't have a horizontal asymptote. Okay, so my domain is just going to be restricted by my vertical asymptote. So x cannot equal negative 2. My range is restricted by my horizontal asymptote or holes, but there is neither of those. So all real numbers is going to be my range. So let's graph this guy. I got negative 2. I know I'm going to hit 3, 0 and negative 3, 0. Those are my 2 x-intercepts. And if you go ahead and plot this guy in your calculator or Desmos, you get this kind of interesting looking graph that looks something like this right here. Okay, and then for number 2, okay, I'm going to go ahead and factor this guy. This guy is x minus 5 times x plus 1 over x plus 1 times x minus 1. So right off the bat, I noticed x plus 1 cancels, so that means I'm going to have a hole with an x value of negative 1. Remember, you got to set that guy equal to 0. And then my x-intercept, I set x minus 5 equal to 0. My new function looks like this, right? And that's just going to give me positive 5 when I set that equal to 0 and solve. My vertical asymptote is going to be at what I get when I do x minus 1 equal to 0, and that's going to give me positive 1. And then my horizontal asymptote, I look at the degrees, it looks like they're both the same, right? If the degree of p is equal to the degree of q, we just simplify it down. 1 over 1, that's like their leading coefficient. The number out in front is just 1. Okay, so the last thing I'm going to do before I do the domain and range is figure out the y value for my hole. So I'm going to plug a negative 1 in to each of these. That's going to be negative 6, right, over negative 2. Negative 6 over negative 2 is positive 3, right? So the things that are restricting my domain are going to be my vertical asymptote, so x cannot equal 1, and also my hole, which is negative 1. The things restricting my range are going to be my horizontal asymptote, which is 1, and my hole, which is 3 for the y value. Now we have a bunch of information here. Let's plot all this. Vertical asymptote at x equals 1. 5, 0 is our x-intercept. We can plot a point there. We know we're going to hit that. We have a horizontal asymptote at y equals 1. We have a hole at negative 1, comma 3. So draw a hole like that. And then if we go ahead and plot this guy, we should get something that looks like this. Remember, you can use Desmos or your graphing calculator. Okay. And there you go. All right, so to practice, we are going to go ahead and jump over to homework number 8. Okay, and I want you guys just doing homework 8, numbers 1 through, let's do 1 through 5. Homework 8, 1 through 5. Okay, have a good day, guys.